Today we will learn how to build non-unit fractions less than one whole. What we have here is a one whole that has been partitioned into 5 equal parts. 2 of them are shaded and 3 of them are not. If we make a fraction for the shaded part, we can use the fraction 2/5. And for the unshaded part, we can use the fraction 3/5. If we put these two fractions together, we will have 5/5. That becomes a whole. Let's see this second example. We have a whole that has been partitioned into equal parts, in 10 equal parts. Some of these parts are shaded. Let's count to see how many parts are shaded. 1, 2, 3, 4, 5, 6, 7. 7 pieces are shaded. So the fraction that I can use for this shaded part is 7/10. Now let's count the ones that are not shaded. The parts that are not shaded are 1, 2, and 3. The fraction that I would use to represent these parts are 3/10. If we bring these two fractions together, it becomes 10/10, which is the same as one whole because I'm taking all the parts. One more exercise. This whole has been partitioned into 8 parts. We have 6 of them that have been shaded. So we can use the fraction 6/8 to show our shaded parts. 2 of them are not shaded. What fraction do we use to show that? We use 2/8. If we bring them together, the unshaded and the shaded parts, it gives us a total of 8/8, which is the same as one whole. Okay, let's look at this problem. Look what it says. Mr. Stevens bought 8 liters of soda for a party. His guests drank 1 liter. We have to answer two questions. A, what fraction of the soda did his guest drink? And B, what fraction of the soda was left? So we're going to start with the A, and we're going to see what information we have. So we know in total we have 8 liters of soda for a party. So we're going to represent it using a whole, right? And this whole is going to be partitioned in 8 liters of soda. So we're going to try to make 8 pieces that look kind of the same. 3, 4, 5, 6, 7, and I have to add 1, 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. These 8 liters would represent the total that Mr. Stevens had for his party, correct? Okay, and the question says, let's see. His guest drank 1 liter. So all the people that were in the party, they drank 1 liter. So I'm going to shade how many parts right here? Only 1 part, because it will represent 1 liter. So, okay. So what fraction of soda did his guests drink? What fraction of soda did his guest drink? So if I only have 1 piece of my whole, my fraction will be 1/8. 1 out of 8. 1 liter out of 8. So far, so good. Now, the B. it says what fraction of the soda was left. So here we get back to our model, and we have 8 whole liters, correct? And 1 liter was taken, it was drunk by the guest. How many do we have left? We have 1, 2, 3, 4, 5, 6, 7. We have left 7 out of 8, 7/8. The guest drank 1/8, and Mr. Stevens has left 7/8 of the total amount of drinks. Here we have another example. So here is showing us that we have to shade 2/5. We have to show 2/5. So how many am I going to color from this bar? I'm going to color 1 and 2. So we have represented 2/5 we shaded, and the unshaded part is what? What do we have left? 1, 2, 3. 3/5, correct? If we put these two together, the total will be, we keep the same denominator, we add the 2 top ones, and 5/5 equals to 1 whole. 5/5 is the whole thing. 1, 2, 3, 4, 5. 5/5 equals to 1 whole.